Welcome to Java Tricks. Myself Raz Ahmed, and today I discuss the important topic of Java difference between ArrayList and linked list. So, first of all, I tell you the first point. ArrayList internally uses a dynamic array to store element. So, what does it mean? That in this, the array list is resizable array implementation of the list interface. If the size of the current element is greater than the maximum size of the array, then increase the size of the array. But the size of the array cannot be increased dynamically. So what happens internally is a new array is created and the old array is copied into the new array. So let's take here a few example. Okay, go to here. In this, you see the array list initialization. There is no element right now, but we have inserting the element into the array list. The initial capacity is right now 10. Okay, so when we have to insert the element into this, the initial capacity is full right now. So when we want to add more element, then creating a new array and moving element to a new array, and then the array list size is become 50% increases because internally because internally uh, because internally array list is created and the old array is copied into the new array. So here there is one formula or one algo where how the array list internally works. So old capacity old capacity into 3 divided by 2 plus 1. Okay, so my initial capacity is right now 10 into 3 divided by 2 plus 1. Now the new capacity of the array list become 30 divided by 2 plus 1 equal 16 is my new capacity of the array list. But in case of the linked list internally uses a doubly linked list to store the element. Okay, to store the element in linked list we use doubly linked list, which provide a linear data structure and also used to inherit an abstract class and implement list and dequeue interface. Okay, so you see here this is the diagram of linked list here. In this linked list there are 5 nodes is here. Okay, so a doubly linked list in which each node has 2 pointers to point to previous and next node respectively. Here node 1 represent the head of the list. Okay, so the previous pointer of the head node will always point to null and next pointer of the node will point to the node 2. The next pointer point to the node 2. After that node 2 point to node 3, node 3 point to node 4, node 4 point to node 5, and then null. Node 5 represent the tail of the list whose previous pointer will make to point to node 4. Okay, and next will point to null. After that, here we have know that the limitation of singly linked list is that it can be traversed in only one direction, that is forward, but the doubly linked list has providing an additional pointer that point to the previous node. With the help of previous pointer it can be traversed in forward or backward direction. Now we move to point number 2. So in point number 2, the array list implement list interface and doubly linked list implement list and dequeue interface. So according to diagram, the list interface, okay, so array list and linked list both implement in list interface, but array list only implement list interface, and the linked list implement list and deque interface. Okay, this iterable is the interface and linked list is the class. To linked list implement list and deque interface. Now move to third point. Move to third point. Memory. Linked list has more memory overhead than array list. So in this the array list in this linked list has more memory overhead than array list, because in array list each index only hold actual object, but in case of linked list each node hold both data and address of next and previous node. You see here, this is my node. In this node there is two part. The first part contain the data and second part contain the address. This is my previous pointer, this is my next pointer. So the pointer store the more memory. That's why the linked list store more memory in comparison to the array list. Move to the manipulation. Linked list is better for manipulating data compared to array list. So manipulation with array list is slow because it internally uses an array. If any element is removed from the array, all the bits are shifted in memory. Manipulation with linked list is faster than array list because it uses a doubly linked list, so no bit shifting is required in memory. Okay. After that, access. Array list is better for storing and accessing data as compared to linked list. So linked list is slower in accessing an element since we have to traverse the list one by one to access the right location. So array list is better for storing and accessing data. My sixth point is search operation. The search operation contain the get method as I written here. So search operation fast in array list. Okay, so search operation are fast in array list but not in linked list. So if there are less add and remove operation and more search operation requirement, array list would be best. Okay, so in array list the complexity is big O1, but in linked list the complexity is big On. So for searching any element in the array list complexity is good as compared to linked list complexity. That's why the search operation is best in array list. After moving to my last point, the insert remove operation give good performance in linked list. Okay, so the insert and remove operation give good performance in linked list compared to array list. Hence, if there is requirement of frequent addition and deletion in application, then linked list is best choice, because the linked list is complexity is big O1 and array list complexity is big O n. Okay, so from this we have seen that for insert and removal the linked list is perfect for inserting and removing element in comparison to array list. Okay guys, so that's all from my side. Thank you.